Quadratic formula. Let's say that you're given this equation of 5x raised to second power plus 9x minus 6 equals to 0. And they want us to solve for x. Before you use the quadratic formula, you need to see if this quadratic equation is factorable or not before you use the quadratic formula. So, to factor this equation out, first you need to do is, let's say you're given this quadratic equation and they want us to solve for x, right? So the first thing you need to do is try to factor this quadratic equation out. So you put two parentheses. For the first term right here, 5 times 1 will be 5x squared. As for the negative 6, 6 times 1 equals to positive 6 times negative 1 equals to negative 6. And you have to make sure that will equal to this number, the middle term right here. So positive 6 times x equals to 6x. Negative 1 times 5x equals to minus 5x. So 6x minus 5x equals to x, which is not the same as 9x. So this whole expression times this whole expression right here is not a factor for this quadratic equation. The next factor you could try out is 5x minus 6 times x plus 1. 5x times x equals to 5x squared, which matches the first term of the quadratic equation. And negative 6 times positive 1 equals to negative 6. So it matches the last consonant of the quadratic equation. And you have to check if it equals to 9x. So you take 6x, negative 6x times plus the 5x times the 1. So negative 6x plus 5x equals to negative x. So this factor right here is not a factorable of this quadratic equation. The next thing is to try another factor to see if it's factorable or not. I could try like 5x times x matches this 5x squared. And negative 3 times positive 2 matches the negative 6. And we have to check if this whole factor form right here matches the middle term of the quadratic equation or not. So to check that, you take negative 3 times x, which is negative 3x. Positive 2 times 5x is positive 10x. So negative 3x plus 10x equals to 7x. So the 7x doesn't match this given quadratic equation of 9x. So this is not the factor of that. The last factor you could try is this one. And when you do this one, the 5x times x matches the original equation of 5x squared. Positive 3 times x is positive 3x, minus the 5x times negative 2, which is negative 10x. And when you do a addition of it, 3x minus 10x equals to negative 7x. Negative 7x doesn't match this quadratic equation of the middle term of positive 9x. So notice all this factor that we did just now is not a factor of this quadratic equation. So the last method to use is to use the quadratic formula. The quadratic formula is x equals to negative b plus or minus radical b squared minus 4 times a times c divided by 2a. So the a will be the 5, the b will be the 9, the c will be the -6. Once you have all this letter, all you need to do is just plug it back into the quadratic formula. So the b will be -9 plus or minus radical b squared, which is 9 squared, minus. You always put a minus right here, because if you don't, when you do the calculation, it will be very confusing. So always put the minus, then put down the 4. The a is 5. The c will be -6 according to the given quadratic equation. And the a will be 5 right here. So once you plug in all the number, it's time to calculate this whole expression. So -9 will stay the same, plus or minus always stay the same. The radical stays the same. 9 squared is 81. Put a minus, always put a minus. And then 4 times 5 times -6 is -120. Divided by 2 times 5, which is 10. So this one's the same, this one's the same. Radical 81, the negative times a negative will become positive. So it's positive 120 divided by 10. 81 plus 120 will be 201. So it will be -9 plus or minus radical 201 divided by 10. Once you have this calculation, this plus and minus can be separated out into two answers. So the first one will be -9 plus radical 201 divided by 10. The second one will be -9 minus radical 201 divided by 10. So the answer for this quadratic equation, it will be these two x's. The first one will be this one, the second one will be this one. And notice the sign is different.